Time to solve. Okay, there are multiple strategies for these, and it depends on the structure of the problem. Let me give you some advice that will almost always happen. I would write it down, but it's not a hard and fast rule. If you see an exponent in the variable, let me rephrase that. If you see a variable in the exponent, that's how it's worded, then you're going to go for a logarithm. Not all the time. You could, but it doesn't have to be. So exponent with a variable, logarithm. There are exceptions. You could always do it if you wanted to, but then it's just sometimes more trouble than it's worth. Like this first one. So I'm gonna go kind of old school on this first one, and I'm gonna use the purple pen. There we go. Yay, he's using purple. Okay, so I noticed that 8 and 4 are my base numbers, and what I also know, and you know this too, they're both powers of 2, right? So let's ignore the exponents for just a second. If I wanted to talk about 8, I could really say it's that. Okay, if I want to talk about 4, I could really say it's that. Obviously, these are not equal, but let's just go ahead and put that there because we have exponents to deal with as well. Not a true statement yet. We'll fix it. Because I had a 2x for an exponent here, and I had a 2 for an exponent here. So last time I checked, in a situation like this, you would multiply your exponents. And all this can happen because of logarithms. But basically, I can mark out the 2's. So 6 equals 4x. Therefore, x is 6 divided by 4. That's 1.5. Okay? Alrighty. I would like to go ahead and blurt out the answer to the next one. Well, go ahead, blurt it. No, okay, not yet. Let's pretend like this just said 5. Not 1/5, just 5. 5 to what power would give me 125? 5 times 5 is 25, times 5 again would be 125. So 3, power of 3. But because it being 5, was in the denominator and then it got raised to a power and became a numerator, the exponent was negative. Now, I said earlier that anytime you have a variable in the exponent, you can write it as a logarithm, and we will do so. So I could write this as a log base 1/5 of 125, and that's equal to x. I'm just rewriting it. I'm writing it as an inverse operation, so to speak. So I'm undoing exponentiation. I'm undoing the exponent with a logarithm in this case. So let's grab a calculator, and I want to find out what that is. Neat little thing, just in case no one ever showed you on a calculator, because you're probably used to other technologies other than a graphing calculator, but we need to get used to calculators. So math. Sounds like fun. Don't mind if I do. Press math. We're going to go down, and it is this. It's log base. There is a shortcut, so I don't have to scroll every time. I'll tell you what it is in a minute. But log base, and I can type in exactly what I see, actually. 1/5, 125. The answer is -3. Okay, I knew it, you knew it, but there it is. So shortcut on that log thing. If you press math, the option was actually option A. So I would need to retrieve letter A. So let's back out. Math, and then alpha, and then letter A, which is the math button. So sometimes when I'm doing these, I get in kind of a hurry, and I'll just go math, alpha, math. Boom, there it is. Math, alpha, math, math, alpha, math. And now they're just nested all over. All right, let's move on. E to the x equals 6. Anytime you have a variable in the exponent, you could use a logarithm, and I believe I will, but I'm going to use a natural logarithm in this case because my base is e. It's equal to x in case no one ever told you, and I really hope you've seen this before. If you haven't, no judgment. But there is an understood e here that you don't have to write. It's the same as this 1/5. E is not equal to 1/5, but it's the base. It's the same concept. So I'm just going to find out what the natural log of 6 is. There's a button for it. There it is, see? Natural log 6. Don't even want to close my parentheses. We will round to 3 decimal places in this class at all times. 1.792. There it is. All right, same idea, different problem. What we're going to do first, though, is divide by 3 to make it truly exponential. E to the x plus 2 is equal to 5. And so now I have a variable in the exponent. I did from the beginning, but now it's more manageable. It's in truly exponential form. Natural log of 5 equals x plus 2. Don't have to write the understood e where I just put that random dot. But I do need to find out what the natural log of 5 is, which is a fancy way of saying e to what power will give me 5. Real quick demonstration in case you care. Here's the natural log of 5. But if I did e to that power, I better get 5. There. Now the calculator is only so accurate, which is why I got 4.99999999999, but whatever. So 1.609 is equal to x plus 2. We will take that and subtract 2 from it, and we will get our final answer of negative 0.391. By the way, if this would have stayed as a 0 and not rounded up, I would write the 0. I need 3 decimal places, unless the decimal terminates. All right, do I have a variable in the exponent? No, I don't. But let me show you a cool little trick. A scrap piece of paper I've been using for days. Random number. 81. There we go. You could solve that by taking a square root, right? Totally could. Totally could. Square root of 81 is 9. We do the plus or minus thing in this situation. But notice what just happened. I raised this to a reciprocal power, and I would multiply those exponents. So 2 times 1/2 is going to give me, well, 1. So I have x to the first. I'm going to do the same thing here. I'm going to raise this side to the reciprocal. That's 3/4. I'm going to raise this to the reciprocal power of 3/4. So 3/4. 4/3 times 3/4, well, they cancel. And I'm left with x plus 1, and that's equal to 81 to the 3/4. Well, 81 to the 3/4, I don't want to blurt it out. But I'm going to do it the way we did it on the other side of these notes. Before I press enter, and you're like, oh, here goes. This is really the 4th root of 81, and then I'm going to cube all that. Now, I could cube the 81, then take the 4th root, but that's just, the numbers get too big. The 4th root of 81 is 3. Because 3 times 3 times 3 times 3 gives me 81. And I have 3 cubed, which is 27. So, told you. I don't know why I was about to put x plus, and now I'm bumping the camera. 26. All right. Ooh, this one started as a log. Most of the time when they start as a logarithm, you rewrite them as an exponent. So this is going to be 2 to the 6th equals x. It is the equivalent, or the reverse equivalent, of the process that happened on this one. Started as an exponent and turned into a log. This starts as a log and turns into an exponent. 2 to the 6th power, in case no one ever told you, is 64. There you go. Okay, let's get a little crazy here. And I want to kind of walk you through a process and just go ahead and blurt out answers from the very beginning before I walk you through a process. The answer to this one is 10, and the answer to this one is 10, because e and natural log cancel each other out when they are in this configuration. All right, so here's why. If I wrote this with a base of e, and then did the same process I did here, where I wrote it in exponential form, I would say e to the 10, this e to the 10 equals whatever this is, which is e to the x. Well, if e to the 10 equals e to the x, then 10 equals x. Okay, I told you, right? I could also, in this case, say, old rule, if I have a variable in the exponent, I could use a logarithm. I could have done that here, but it would have taken me a long, it's just not worth the trouble. But if I logged both sides, I'll use a natural log. I would have that. Using some very old, not very old, well, they are old, but some rules that you have seen before recently. I could move this down the front, and I have natural log of x times natural log of e equals natural log of 10. The natural log of e is 1. This part is a question saying e to what power gives me e? E to the first power gives me e. So this is 1. I'm going to mark it out, and I would have the natural log of x equals the natural log of 10. So x is equal to 10. Okay? Shortcut, within these configurations, they cancel. So let's do the same thing, but now within these configurations, they will cancel, and I have 4x plus 1 equals 10. So 4x equals 9, and x is equal to 9/4, which of course is 2 and 1/4. That's okay though. Fractions are fine. And these cancel, but they're not e's and natural logs. Oh, but they are logs. This is a 10, and this is a log base 10. And I have a 10 to the log base 10, and they will cancel. Okay, so 9x is equal to 27, so x is equal to